Welcome to today's lecture on blockchain and understanding the basics of blockchain. What is it all about and how this works in the real world. So I welcome you guys. This is your host Navdeep Sidana. Will be your instructor throughout this course, and let's begin. Let's first understand what is blockchain here. As we already know that it's the basis of Bitcoin and other cryptocurrencies. But is it just that? Is it just a way of keeping in account some digital currency across some servers that are located somewhere? Is it just that? And it turns out that, well, it can be used, this concept of blockchain can be used for keeping an account of something. It could be transactions, it could be funds, it could be tracking, it could be smart contracts that are created between organizations, and much more. So let's understand. And before we get started, it's important for us to know that this is an introduction to a high-level blockchain technology. However, we should acknowledge in the beginning that Satoshi Nakamoto wasn't the first one to create this blockchain based concept. If we just open ethereum.org, Ethereum is another blockchain application based on a different currency like Bitcoin. Same way there's a currency named Ethereum. So here on the white paper that was published by the Ethereum developers at UC Berkeley, it says that the Satoshi Nakamoto development of Bitcoin in 2009 was hailed as a radical development. However, in the history, we have seen some concept of a decentralized based digital currency as well as alternative applications like property registries that have been around for decades. And these anonymous e-cash or electronic cash protocols of 1980s and 1990s were mostly reliant on this cryptographic primitive technology known as Chaumian blinding. It was the first name who provided this currency with a high degree of privacy. But the problem was that this also relied on a centralized intermediary which was giving them this high degree of privacy. It was like a stamp of high degree of privacy, but that was given by a centralized intermediary which wasn't really trustable. It is as if by going to a bank and then getting a KYC for an anonymous bank account. It's not anonymous anymore. It has come into the limelight of the banking, and therefore it defeats its purpose of being an encrypted medium of making transactions. So in 1998, YG money, this is also a crypto anarchy community guy, he also created this medium of exchange to reinforce contracts. This was the first, we can say, the first introduction of contracts, smart contracts. that were basically provided by the government. So government, it's only through a government that you create a contract between two organizations, or like an legal contract between the government and their employee. So there were two protocols here. The first one was impractical, that it uses asynchronous and unjammable anonymous broadcast channel. However, it will motivate the second protocol, which was more practical. In both cases, we assumed that the existence of an untraceable network where sender and receiver were only identified by their pseudo anonyms, which were called as public keys. So these were the two basic concepts, and in the beginning, that were introduced. The first one was Chaumian blinding, while the second one was YD. So these became the first proposal that introduced the idea of creating money by solving some cryptographic puzzles, as well as a decentralized space consensus. But the proposal was scant on detail as to how decentralized currency could be implemented. That is where the shortcoming came. Then in 2005, a guy named Hall Finney introduced this concept of reusable frame of work, or reusable proof of work technology, which the Bitcoin uses today. So it was a system that uses idea from B-Money that was created by YD, and together with Mr. Adam, they created a concept for cryptocurrency once again. But it fell short as to relying on some trusted computing as the backend that any hacker could generate a fake blockchain or a replicated version of this original blockchain and could put it on the real network. And there might be a very low amount of chance of it being identified as fake by the network, and the network might just believe into thinking that it's real. So in 2009, our first implementation of Bitcoin came into practice by Mr. Satoshi Nakamoto, which combined these establishing primitives for managing ownership through public key cryptographies. And these public keys can only be decrypted by a private key. With the consensus algorithm working at the back end for keeping an account of who owns these coins, also known as the proof of work or proof of ledger. So what blockchain really is a ledger that is keeping an account of all of these transactions that are happening over the network. And today there are various flavors of Bitcoin that are available: Bitcoin Cash, Zcash, and lots of other flavors. And those flavors basically are generalizing these blockchain with samples. And additionally, we recommend you that you do some research and prototyping with due diligence before making any long-term decision into these blockchain based networks. Use your natural ability to make decisions before making any sort of that. So during the 2005 financial crisis. Uh, this was the bank record. There is a party A's record that is paying to party B. This is what a blockchain really is, that it's showing you that there have been a transfer of funds. This is what that block is actually holding. That is, this is a traditional banking system on our left, and on the right here we can see the digital side encrypted transaction and ledger, which we also call as hyperledger. What this hyperledger really is it's having a chain of these ledgers. That's where the hyperledger comes, this name comes. It's having the information of a party or a sender paying some amount or something to the receiver. Now this doesn't need to be money. It could be like the COVID-19 Arogya Setu app that was released in 2020. We can think of a blockchain based model that if anyone using your mobile based devices through the near field communication network, you can identify if anyone comes in between say 1 feet of radius into near your device. It will automatically take in a block, some amount of data from that particular device to your device, and you'll be marked as signed, or maybe that you have come into the other person's state, and you might be having some chance of getting affected. Now that you are affected or not, that is another topic of discussion into healthcare, so we're not gonna dive in that. But yes, there is not just a cryptocurrency based application of blockchain. This could be used for creating contracts between companies, between two different parties. This can be used for as an architecture in your financial company, in your any company, and as a proof of work, as the amount of work you do in an organization, you get some sort of reward for that. Like you're mining cryptocurrency, here you are mining cryptocurrency by doing actual work, and you get a reward for that, doing that work, for verifying a transaction. So here the auditor is doing is that he's verifying a transaction on the blockchain, that this transaction is genuine and there's no hacker who's trying to generate these funds artificially and then putting them on the network. Now this auditor could be replaced by an employee who's doing some work for an organization, and as a reward he gets some amount of that cryptocurrency. So there are lots of sectors into which blockchain can be implemented, and you can lots of decentralized based application that blockchain has, where the bank doesn't own the money, but the money is actually owned by the people. Now what happens if bank is not there someday in a banking system? Your money is also not there. Your money is gone along with the bank, because banks own that money. Like if some banks go bankrupt, like say Yes Bank or Axis Bank or some other bank, like God forbid this doesn't happen, so, and we don't lose our money, but in case that happens, let's take an example, like economies can crash, stock market can crash, weather can change, and there's no possibility that our funds are still there, because banks own that funds. It's the banking authority, it's a centralized authority that owns that funds. So what Bitcoin really does is that it's a peer-to-peer electronic cash framework that would allow your payment to be sent directly from one party to the other without going through a bank. So you don't need a bank. If the banking server is down, no problems, you can still send money. And the way that you were able to verify the origin of that money would be by some proof of work, using some of your CPU computation power and decrypting that puzzle, that ledger puzzle, to be able to understand that yes, indeed it is genuine funds and it's not some hacker or some other fraudulent authority or some fraudulent person who's trying to impersonate legit funds on the paper. So in case when we talk about digital currency, there are lots of cryptocurrencies are there. Like in today's time, there's also normal banking currency. So if we replace those currency, that cash, with number and codes, we arrive to digital currency. And the advantage of this kind of money is that it's fast, it's international, you can send payment across borders, you can using Bitcoin, using Ethereum, using any sort of cryptocurrency. It's valid everywhere. Any person in any country, it doesn't have to be that there has to be a bank for the person to be able to receive his or her Bitcoin in some part of South Africa or some part of West Indies or anywhere in the world. As long as the person has a working internet connection, he or she should be able to receive this digital currency without having any sort of issues. And there's easy accounting. There's not a problem like with cash. You have to sit down with a CA and calculate like how much sales you did in case you're accounting in cash. When you're accounting in Bitcoin, there's no problem with accounting. There's easy accounting because all of your Bitcoin ledger, this blockchain, will only have all of these transactions, and it's not possible that you can lose this kind of digital record, as it works on a fault tolerant architecture. It weighs nothing, and like it takes some amount of money and effort to generate coins, to create coins in a factory or at the RBI or the central bank or the World Bank facility, and some amount of effort. It is cheap. Creating this kind of cryptocurrency is cheap, while creating a bank can cost us 500 crore rupees, while creating a cryptocurrency just takes in some developers, some creative critical thinking, and a few thousand lines of code, depending upon the kind of architecture that you're looking to implement. Now let's discuss what's the problem. Like, why do we need this kind of currency, this kind of digital currency? Won't our normal currency just do the job with a few upgrades? Just like downloading attachments from the email, where it's hard to distinguish between the legits and the counterfeits. The same way can be with digital currency, that if there's no block of code that is verifying its attachment in the chain of other blocks, somebody from some more technical and financial background, say someone working for Paytm, might be able to just create some fake Paytm currency, right? So it's hard to distinguish the counterfeits and ownership problem, that who owns that piece of money, if it's Paytm or some banking authority or some financial authority. And in the banking system, there are sometimes, as we as payment makers, while making payment, there have been some issues with double spending, that the shopkeeper hasn't received his payment and yet, or the payment failed, it said failed, the amount was deducted, and the person thinking that, okay, if the payment has failed, the amount should be refunded to me, and he makes another payment, and after 48 hours or 24 hours, on the next banking day, next business day, we end up seeing that both of the payments have been successful, and we ended up making double payments. That's okay sometimes, like if the shopkeeper is nearby, and we can just go and ask him that, please check your account, it says payment has been made twice. And it is subject that, depending upon the kind of person also, as you never know what kind of person you might be dealing with, and he might say no, or he might not be even have a conversation with you. Sometimes with big corporate tech companies, when you're making payments into their bank accounts, sometimes it can get really difficult to get your payment back. So it's a subject to many different things, but if you're far from the shopkeeper or that shop, then getting a refund is out of the question. You might need to do some several hours of effort to get across a communication channel, to communicate with the shopkeeper via WhatsApp or some other medium, maybe calling, or some other way, maybe calling their bank and getting their registered mobile number or something like that, which can take, and the bank also can deny disclosing their customer personal information. So yeah, things can get really difficult trying to get your payment back. So, and networks are noisy sometimes. The server has too much traffic sometimes, like Flipkart or Amazon or something like that. And supposedly there's some sale happening on Amazon website, and there are, say, 10 lakh users trying to make a payment for a new mobile device that has been released, maybe a new version of iPhone or Android, or some new laptop or gaming computer, something. And there might be a super sale organized by the Amazon, where lots of people are trying to make payment at the same time. So network can get very noisy, and also transmission across networks is far. So say some guy is making some payment from, say, Tamil Nadu, and while the banking server is, say, in Gujarat, there could be a delay, instantaneous delay. And moreover, like, hackers can capitalize on these kind of digital payments. They can get your card details and try to make payment on your behalf for stealing your funds. And fraud detection could be a problem here, in trying to make sure that it's only you who's trying to make the payment, not somebody else who is impersonating you to make payment on your behalf for his or her own profit. So how can we solve this kind of problems? So Satoshi was determined to find these centralized parts of banks, that is the ledger, and he thinks, okay, what if I just turn this bank inside out? Instead of one central authority controlling the ledger, instead of the bank controlling your funds, what if every user were recruited to maintain a constant updated copy of that kind of data? And what if the power was with people and not with the banks? And the strength of that digital copy was so perfect that it was everywhere instantly, that anyone who's using Bitcoin will have a blockchain on their own devices on which they're using, and any one ledger with even one common not agreeing among the masses will be discarded, leaving the fraudsters almost powerless. So like multi-signature, like joint accounts, somebody else can impersonate and sign on the other person's behalf to withdraw some funds, while in case of this kind of blockchain based technology, this can be avoided. With even one person not agreeing, with the masses would be discarded. So until or unless that person doesn't sign the transaction, it can't happen. So these are some examples of, again, some smart contracts. And last but not the least, replacing cash with a statement or ledger. Now let's see, how does a ledger look like? So in the ancient times, this is a typical look of a ledger, that is keeping an account of all of the different persons and their what kind of details do they have to make sure that we are on the right page. So each person who's using blockchain or Bitcoin will have this copy of ledger. So it's impossible to make a fake payment or trying to or give a fake check to someone, like happens with these days also sometimes. So when we talk about replacing cash with ledger, we mean replacing it in a decentralized way. Now this is a centralized architecture on the very left, where we see if the centralized authority is not there anymore, there couldn't be any payment or anything that could be happening. But what if the power is with people? It's the people that own the network and not the centralized authority, not the banks which own the money, but the people own the money. And what if this decentralized ledger could be distributed and be made public across? So each of the users are also not putting their identities and their personal information at risk by these corporates to analyze their transaction and create some marketing campaigns around it, like the banks do. But they maintains a degree of anonymity while making payment, and each user has a copy of the ledger and participates in confirming the transactions independently. There's no problem with double payments. There's no problem with network being too noisy or some transaction being deducted from your account but the other person hasn't been credited yet. So getting into a bit more detail, so Satoshi paired with two main technologies. The first one was proof of work, and the second one was elliptic curves. What elliptic curves really did was it gave a unique access to ledger for every person. And last but not least, what we discussed here in this lecture was about the brief history of Bitcoin, blockchain, how it came into existence, what all advantages it had over the previous centralized system, and how this decentralized hyperledger based chains of blocks, which is called blockchain, a peer-to-peer network, solved all of that problem. Could be the solution to everything, and not just cryptocurrencies. It could be applied in multiple dimensions of domains across the whole sector of economy and solve a variety of problems, which we'll be discussing also in the coming lectures ahead, guys. And do let me know how was this lecture. You can write me something in the message box or the comments below, or you can simply ask questions now. If anyone has any questions, any doubts, feel free to ask. And in the next lecture, we'll be taking a bit more detail into the actual workings of how this technology really works at the molecular level, and also seeing what kind of problems it could solve with that kind of implementation, with that kind of an architecture, with that kind of concept. What all different sectors in economy can be dealt with, and making work a bit more easier, maybe avoid more corruption or something like that. We don't know yet, we'll see. So lots of interesting lectures and content coming up ahead, guys. Do stay tuned, and happy learning.